Good afternoon, Isabel. How are you doing this afternoon? I am doing well. Just think, next week at this time, you will be done with the AP exam. It's got to be a relief. Now, um, there is, after this week, there is no more new material. Well, there's no new material this week either. We're just reviewing. But next week, after next week, you are on your own. If you want to go back and retake some assessments, you absolutely can. Or if you just want to be done with AP Calc, you are done with AP Calc. There's no exam. There's nothing new in weeks 15, 16, 17, and 18. So once you have the exam taken next week, you are done with the class. Okay. Again, as I said, you can always go back and retake assessments and stuff like that, but I think all of yours are advanced anyway, so it doesn't really make any difference. Okay. So this week is the last week of class, basically. What we're going to do this week is we're going to review separation of variables. We're going to talk about a little bit about particle motion from last week. Let's say they give you the velocity in feet per second of a particle moving along a line, is where the time, v of t is equal to t to the third minus 10t squared plus 29t minus 20, where t is time in seconds. What is the displacement of the particle on the interval? What is the total distance traveled by the particle? Okay, so I would like you to solve that. I mean, you should be able to do this without a calculator, but I think it would take, I suppose it wouldn't take too long. But you could never, the total distance you could never do without a calculator because that's the value, and that's the whole thing I was trying to get across here. So what I'd like you to do is I'd like you to do both of these problems on your calculator. Let's see what you get for those two problems on your calculator. So just plug in, again, I would just go to my calculator and I would just plug in y sub 1 is equal to, and then you can just use your calculator to solve these. So let's see what you get for an answer. I'm going to do it on my calculator too to make sure I get the same thing. 10.67, that's exactly what I came up with for part A. And that one, all I did is I just took the integral from 1 to 5 of y1. Correct. Very good. And what do you get for part B? Total distance is going to be the absolute value of velocity. So basically what you're going to have to do is you're going to have to do the absolute value of y1 in your calculator. Do you know where the absolute value button is in your calculator? Okay. You got 0.54. That's not what I had. But then again, my calculator's a piece of junk. Let me see if I can put this in again. Okay, so I'm going to clear that out. So math. Okay. I was going to say I didn't get 0.54. And really, you kind of figure it has to be more than the displacement, right? Because if you have, let's say I gave you, I'm just going to give you a graph also and see if you can come up with some answers here. All right, did you get a new answer? That's what I came up with. Okay, all right, good, 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 good. Okay, so now let's say that this is a velocity graph right here. Okay, let's make this 6. All right. If this is a velocity graph and they gave you something like this, what is the displacement of this object? We can say it's feet or miles or whatever. So what is the displacement? And there really isn't any work to do on this problem. You just have to look at it and realize 14? Nope. 14 would be the total distance traveled. Okay, because everything above the x-axis, the object is going to the right. That is correct. So the displacement, so it went 5 places to the right, then it went 6 places to the left, then it went 3 places to the right. So if I had to draw this out on a number line, if I start at 0 here, and we don't know where it starts, but I'm going 5 places to the right because it's above the x-axis, and then I'm going to go 6 places to the left, so that means I'm at -1 now, but then I'm going to turn around and go back 3 places, so it looks like I end up at +2. Now, if they ask for total distance traveled, well, that's absolute value, so all of these would be positive. This would be +5 plus +6 plus +3 or 14. So big difference between displacement and total distance traveled. Okay, good with that? All right, let's try this problem. So on an AP test, they would give us something like this. And you might have seen, I mean, a lot of these problems you probably have seen over and over again because I do put some of the same problems in our assessment. But what I'd like you to do is I'd like you to plug that function into your calculator, and then we're going to answer the questions along there. Okay? So, and I'm going to do the same thing. So I got to make sure I put this into my calculator correctly. Let's see here. Okay, so I've got it in my calculator. And then the first question, it said find the acceleration. So this is a velocity function, okay? So what is the acceleration at time t is equal to 3? -2.11. That is absolutely correct. What is, now let's go back. What if I asked you at time t is equal to 3, is a particle speeding up or slowing down? Okay. And in order to find, I don't think they asked that on this problem, if I'm not. Okay, they don't ask it. Okay, so in this problem, it's velocity at 3 and acceleration at 3. So I know the acceleration is negative here. What is the velocity at 3? Okay, and I would just plug that in. Negative. Okay, so they're both, as long as they're both, if they're both the same sign, doesn't matter if they're both negative, both positive, that means the particle is speeding up. If velocity and acceleration, same sign, particle speeding up. Velocity and acceleration are opposite signs, slowing down. Yes, that's exactly how I would have gotten it also. I would have just went to my table, plugged in 3, found my value. Absolutely, that's exactly how I would have gotten it. Excellent. Okay, so part B, it says find the position of the particle at time t is equal to 3. Okay, so this one's a little bit tougher and when you think about it, because position they gave us a point. They said that at t is equal to 0, so time 0, particles at -5, right? So when x of 0 is equal to -5. Well, so if I wanted to find the position of this particle, it's going to be x of 0 plus the integral from 0 to 3 of v of t, because position is area underneath the curve, right? So what would you get if you did that? And x of 0 we already know is -5, right? This is just -5 plus whatever that is. Just trying to get us using our calculators here. -1.76. That is absolutely correct. Excellent. Part C. Now this is the 2018 exam problem. Usually there's always a particle motion problem. Very, you've done enough problems now, right, with AP questions. Are you starting to see a pattern to these? Like when we did the relative rate one, the ones with you shoveling snow off or the gravel coming in, stuff like that. You see a pattern to most of these problems. They ask very similar questions on almost every single AP exam. They'll just have, this, you look at this problem and say, oh my goodness, that is like one crazy function. But it's a calculator-based problem, so it shouldn't cause too many problems. Now, part C, it says evaluate the integral from 0 to 3.5 of v of t, and evaluate the integral from 0 to 3.5 of the absolute value of v of t. Interpret the meaning of each integral. Okay, so what is the first one giving us? What is the integral from 0 to 3.5 of v of t? What does that give us? Exactly. And what does the integral from 0 to 3.5 of the absolute value? Total distance. Exactly right. And we obviously could figure those values out just by plugging them into our calculator. So what do you get for the displacement? .84 is correct. Very good. What is now, the next one is total distance traveled. It has to be at least 2.84, correct? If you get a number less than that, you did something wrong, because there's displacement and total distance. Total distance has to always be equal to or greater than displacement. .73. It's exactly what I came up with. All right, now, part D. This is the hard one, okay? They usually they start off easy, get a little bit tougher, a little bit tougher. Part D, it says a second particle moves along the x-axis with a position of t squared minus t between 0 and 3.5. At what time t are the two particles moving with the same velocity? Okay, how do you think you're going to figure that out? Okay, now remember, one of them is a velocity function and the other one is a position function, right? So you got to remember that, because it says the second particle moves along the x-axis with the position given. Okay, so that's not a velocity function, that's a position function. All right, so what is your answer? I'm gonna see if I can get the answer too. Oh no, my calculator just turned off. I know my batteries are starting to die on this thing. I can barely see it. All right, so this will help you with points of intersection also, hopefully. Do you know how to do points of intersection? Having trouble with plugging in the equations. Well, you already should have the first equation in, right? The v of t is equal to 10 sine blah, blah, blah over t squared minus t plus 3. And the second equation is just, I would just take the derivative of that, because remember, the derivative of position is acceleration. So 2t minus 1. Right, because this is a position function. We want to know the velocity. So if you take a look down here, velocity is 2t minus 1, and then you look for where it crosses. Now, this is really important. I just want to make sure you know how to find the point of intersection. Because when you have a calculator and you can do this, it makes it really easy. Okay. Now, what you're going to, so in your calculator, you have y1, y2, correct? Okay. So when you graph it out, I look here and it's like, okay, I know when I do my windows, okay, so I'm going to go to my windows. I'm going to probably put in maybe 0 to maybe 4, okay, because I know my window doesn't have to be any bigger than this because it says between 0 and 3.5. So I'm just going to go from 0 to 4, and then my y-min, I might go from maybe -2 to maybe 5 or 6. I don't know how high up it's going to go. Oops. Okay, so then I'm going to graph it, and I get a graph that looks, okay, so this one, it looks like this. Okay, and then my other equation is a straight line, obviously, because it's 2t minus 1, so it looks something like this. All right, so I'm looking for this point right here. That's a point of intersection. So what I do is I go to calculate on the top of the graph, or the calculator way at the top. So you go, I think it's like second trace or something like that. So you see the calculate button. Okay, go down to intersect. So on my calculator, it's number 5. Okay, and what it does is it puts a cursor on your screen. Okay, you see the cursor. No, we know that can't be right. Okay, why do I know it can't be right? Because time has to be between 0 and 3.5. That cursor is just on there. What you're going to do is you're going to move this cursor to the left of the point of intersection. I don't care where you move it. You can move it any place to the left, and then you hit enter. So I'm doing that right now with my calculator. I'm just moving my cursor to the left side of the point of intersection. I'm going to hit enter. And then I'm going to move that cursor, and all you do is use the arrow keys. Then I'm going to move my cursor to the right side of the point of intersection. Doesn't matter how far you move it, makes no difference at all. Hit enter. Then it says guess, hit enter again. And what it will do, it will calculate the point of intersection. 1.57 is exactly what I came up with. Okay, so that's how you find point of intersection. Now, I think I'm wrong, tell you the truth, because it's been a while I've done point of intersection. I think when you do cursor, it just goes first curve, second curve. So when I do second calc, I'm going to do this again, point of intersection. So first curve, so you say yes, and then you move your cursor to the second curve. So you have to have it on the first curve, then the second curve, and then hit enter, and it will give you the point of intersection. Okay, so 1.57. All right, so in this problem right here, here are all the values. This was a fairly easy, I thought it was a fairly easy particle motion problem. Most of the particle motion problems are fairly easy. 1 point for finding the acceleration, 3 points for finding the position of the particle, 2 points, or no, 3 points for finding the displacement and the total distance. And then part D, 2 points for finding where the two graphs, the two velocities are the same. So, you know, I am positive that you would get at least 5 points on this problem. Okay, do you think you're pretty good with these types of problems? All right. Next thing that we're going to talk about today is slope fields and separation of variables. Now, we did these this semester, but I just want to make sure we go over it because this is like the last thing that, you know, we've done, you know, a lot of stuff this semester. And when you think about it, it's a short semester because you have the AP exam, but we did area under curves, we did volumes of rotations, we did separation of variables, we did integrals, displacement, all that kind of stuff. So now, last year they did not have a slope field problem on the test. They did have a separation of variables. They didn't make the students do the slope field, but I just want to make sure that we remember how to do this. Remember, all you do is you just take the values. So here the dots are at 0, 0, 0, 1, and I'm not going to do all of them, 0, 2. And then you just plug it in. This is your function. It's the derivative. It's really y prime. So this gives us the slope at any given point. Well, if I put 0, 0 in here, I end up with 0 over -1, which is 0. If I put 0, 1 in here, so that gives me -1 on the bottom, 1 on top, so that's -1. If I put 0, 2, that gives me -1 on the bottom, 4 on top, so that would be -4. So if I did my slope field, it would be 0 here, -1 here, -4 here. -4 would be going way down fast. Okay. So if you see a slope field problem, that's probably one of the easiest points you're going to get. Okay. But let's talk about parts B and C. It's a little bit harder. Okay. Part B. It says, let y equal f of x be a particular solution to the given differential equation with the initial condition 2, 3. So they just gave me a point. Okay. Point 2, 3. Write an equation for the line tangent to the graph of y is equal to f of x at x equals 2. Use your approximation or use your equation to approximate 2.1. Well, we've got our point. The only other thing we need is slope. Well, here's where I find my slope. So if I put 2, 3 in here, 3 squared is 9. If I put 2 down here, 2 minus 1 is 1. So my slope is 9. So my equation, y minus 3 equals 9 x minus 2. Never, ever rewrite this in slope-intercept form. Just leave it like this. They will not take off points, and it takes up time, so just leave it. And then it said to approximate the value at 2.1. So we're going to put 2.1 in here. So 2.1 minus 2 is 0.1, so 9 times 0.1 is 0.9. Add 3, so that's 3.9. Boom. Fairly easy problem. Okay, this is fairly easy. This was fairly easy. This is where it gets tough. So it says find a particular solution to the given differential equation with the initial condition 2, 3. So basically they want us to write an equation for, we have y prime, they want us to write y is equal to. Boom. They gave us a value here. Okay, so how do we do that? Do you remember doing these before? Okay, first step, separation of variables. We get the x's on one side, we get the y's on one side. So I would rewrite this as dy over y squared is equal to dx over x minus 1. Okay. Then I have to take the integral of both sides because I'm trying to go backwards. I'm trying to get y is equal to. I have the derivative. I want to get the original function. So I'm going to rewrite this as y to the negative second dy is equal to, this one I can't change, dx over x minus 1. If I take the integral here, I get y to the negative 1 over negative 1 is equal to, well, this is natural log of x minus 1 plus c. Now, I always tell students, as soon as you take this, you want to find your c value. Now, if there's a negative variable, I would change that out. So I might rewrite this as this. Okay, so I want to find my c value. Well, I know they gave me a 0.23. Okay, so we know this point. So I'm going to put 3 in for y, so that's negative 1 over 3 is equal to natural log of 2 minus 1, which is natural log of 1 plus c. You know what the natural log of 1 is? It is 0. Okay, so that's 0. So c is equal to negative 1/3. All right, now that I have that, I put it back in here, and I have to solve. I guess I would have put it in here because I have, so this is negative 1 over y is equal to natural log of x minus 1 minus 1/3. Okay? And I look at this problem, it's like, oh, if I can get a 3 down here, I could just flip this whole thing over. So I'm going to just put a 3 here and flip this over. So you're really looking for y is equal to, and I could put negatives on there also. So natural log of x minus 1 plus 1 over 3. Now, there's many, many ways you could rewrite this. I could rewrite this as log base e of x plus 1, and you know, there's just oh, I flipped it over the wrong way, didn't I? It should have been 3 over. So natural log of x minus 1 plus 1. All right. So these are types of problems, separation variables. It's one of those key things that they want you to be able to do. So let's take a look at the answer key here. So here's the slope field. 2 points for being able to get the slope field. That's pretty good. 2 points just to write the equation and come up with 3.9 there. And then here is the work for the other problem. We came up with c is equal to 1/3. So separation of variables, you get a point there. You get 2 points just to be able to take the integral. 1 point to find the c value. And then solve for y is another point. So, you know, all of those points, you're really trying to get 5 points total. If you get more, awesome. But that 5 points is what you're really shooting for each problem. All right. Any questions on that problem? All right. So now I want to go through some multiple choice practice. So this week, I believe, and let me go in and check. I'm not 100% sure, and I don't want to lie to you. I think you have another AP review, okay? And I put the answer key in there for the, I don't have the answer key for the multiple choice because obviously the multiple choice has the answers, but so week 14, you have a slope field, separation of variables, and then you have another exam practice, okay? I'm going to tell you this, and I want you to, you know, some kids, they listen, some kids, they don't. You can get burnt out with math, okay? You can do as many problems as you possibly can. My suggestion is, after Friday, don't look at any more math at all. You know, you can, and up till Friday, you know, I would say, hey, you know, look, you know, go back and go over those the practice AP exams, because the more times you see a problem, and it doesn't even matter if it's the same problem over and over and over again, after a while, it's like, oh, this is what they're trying to get for that problem. So I would say, you know, if you get all the work done this week and you have a little bit of time left over before Friday, maybe go back, look at the exam reviews again. But after Friday, I would say not to look at any other math, because you've got to just clear your head. You just have to figure out that it's like, okay, I've got enough. I understand what I'm doing. And then go in on Monday refreshed, get outside over the weekend. And then on Monday, go in refreshed and do your very best. That's all you can do. Oh man. You have AP exams all week this week from Wednesday to Friday. Oh my goodness. Okay, so let me tell you another thing. If you feel comfortable, okay, you don't have to do this week stuff. You don't. You do not have to do this stuff's material. You can do it after the AP test. I mean, I'm not going to say, hey, this has to be done. I've had other students that didn't want to do it on the computer, so they're just doing problems that they had out of a textbook, and that's perfectly fine. Whatever way you think will help you stay sane and know the stuff, that's fine. You can do, as I said, weeks 15, 16, and 17. There's nothing. And 18, we don't have a final exam in this class. So if you want to do this material next week or the week after, that's perfectly fine. I do not care. If you feel like you're good with the math, you do whatever is right for you. All right? And if you have to study for your other tests, by all means, study for your other tests. All right. All right. So the last thing I have, I think I have like 5 multiple choice questions here that I just want to go through, just to get you in the habit of doing multiple choice, because, obviously it starts off, I forget what the numbers are. There are like 28 multiple choice questions that you can use your calculator for, and then there's like 15 that you can't use your calculator. So I just want to do some multiple choice, just get us in the hang of doing them. So here's a problem. It says find the instantaneous rate of change of the function f of x equals x squared plus 2x over x plus 1 at x equals 3. Okay, so I'm going to let you work that out, see what you get for an answer, and then we'll go through and see if I get the same answer as you do. All right. And when you get your answer, just throw it up on the board and or in the chat, and we'll go through and see if we get the same thing. Letter B. It's exactly what I got. Tell me what they were seeing, if you understood in this problem. Because it's always nice to see how to find a derivative, right? And you had to use the quotient rule, right? So in this problem, I'm looking at this. Do I need the quotient rule? Oh, I don't even think I need the quotient rule. I think I used the quotient rule, but boy, if I would have looked and factored this, x plus 2. Oh, maybe you do. Yeah, I don't think that. I think you do. Yep. I was going to say, oh, it looks like I could factor that, but I don't think you can. So u is equal to x squared plus 2x. Yeah, I'm thinking I could do that easier, but I guess not. So u prime is equal to 2x plus 2. V is equal to x plus 1. V prime is equal to 1. Inside, so I've got 2x plus 2 times x plus 1 minus outside, which is x squared plus 2x times 1, which I don't have to do, all over bottom squared, x plus 1 squared. Now, do I have to simplify this? Absolutely not. I mean, this is a problem where they want us to find the instantaneous rate of change at 3. I don't have to do anything else. I'm just going to put 3 in here. So that's 6 plus 2, that's 8 times 4 minus 3 squared is 9 plus 6, so that's 15. And over here, this is going to be 4, so that's 16 on the bottom. 32 minus 15 is 17, so letter B, 17 over 16. So on problems like this, you know, I always made you guys simplify everything out, right? You don't have to in a problem like this because, you know, it's multiple choice. You get it to the point where you can plug your number in, plug your number in. All right, number 2. What is the x-coordinate of the point of inflection on the graph of y is equal to 2 to the third x, 2/3 x to the third minus 2x squared plus 7? So what is the point of inflection? All right, see what you do on that one. I don't know what that means. I did something wrong because I don't see my answer, but I was using the candidates test. What does that mean? Candidates test. Now, if I was going to do this problem, I always think about first and second derivative test. First derivative test. Okay, first derivative test gives us max mins, and it also gives us where something is increasing and decreasing. Second derivative test gives us points of inflection. So right away, a point of inflection, when I see point of inflection, I'm thinking second derivative test. So first thing I did in this problem is I said, okay, I need the second derivative. So the first derivative is bring down to 3 there. So that's what, 2x to the second minus 4x. Second derivative is 4x minus 4. Set it equal to 0 because that's where you're going to find points of inflection, is where it changes from positive to negative. So if I factor out a 4, I end up with x minus 1. So x equals 1. That is the only place, and then if I had to do my table, it would be negative infinity to 1 and 1 to infinity. But I don't even have to make my table out because I know that is the only place it could have a point of inflection because I'm looking at my answers here, and there's only one that has it. Now, if they had one that said no point of inflection, then I would have to make my table out and make sure that this went from positive to negative or negative to positive, because point of inflection is where it changes from positive to negative or negative to positive. Does that make sense? Okay, so anytime you see point of inflection, you should always be thinking second derivative test on that one. Next problem. It says the graph of f of x is shown in the figure above. Which of the following could be the graph of f prime of x? Okay, so give that one a shot and see what you get. Letter E. That is exactly what I had. Now, when I do these types of problems, first thing I do is I look for parts where it's a max or min. This is a min, up here's a max, there's a min. I know that they have to cross the x-axis at a max or min. So here looks like it might cross right there. This one looks like it might cross right here. And I don't have to be perfect. And then I have so it's going to cross here. So max mins are where it crosses. Now it's decreasing here, so that means it's below the x-axis. It's increasing here, so I know it's above the x-axis. Then it goes below the x-axis. So I'm looking for a graph that looks something that has this shape. It doesn't have to be exact. It just has to have this shape to it. And E is the only one that has that shape. So yes, E is correct. Very good. And this problem here, it says an equation for a line tangent to the graph of y is equal to 1 plus tangent 2x at the point 0, 1 is. Okay, so I'll let you try that one and see what you get for there. Okay, now secant is the same thing as 1 over cosine. Okay, so what I did is I said, okay, secant of 0 is equal to 1 over cosine of 0. Well, I know what the cosine graph looks like. It starts up here, goes down, comes back up. Cosine of 0 is 1. So secant of 0 is 1 over 1, which is 1. Letter D. That's exactly what I came up with. Seems like you've got your stuff. You understand your material. All right. Last slide. good luck on the AP exam next Monday. As I said, I would not study so much. You can overdo it. You know your stuff. Just go in there, be confident, get a good night's rest, have a good breakfast in the morning, and go and do your very best. That is it for AP or AB Calculus. Good luck on your on your test. All right. Bye.